All right, so we're going to continue section 11.1 with the second part, measures of variation. We're still discussing Stephen Curry's points scored in the 2015 Western Conference playoffs. These are the points scored in each of his first 15 games in the Western Conference playoffs 2015. So we talked about this in the last video here. We took these values and found the mean, median, and mode. Talked about the effect that an outlier has on them. And so now we're going to look at two other measures that we can calculate. Connected to the measures of center are the measures of variation. And these are measures that describe the spread or distribution of a data set. And there are two of these that we're going to discuss today, range and standard deviation. Range is pretty quick. In order to determine range, we only need to find the difference of the greatest value and the least value. We take the largest number of the data set and subtract the smallest number of the data set from that. So that's how you calculate range. The standard deviation is a little bit trickier, but it comes with a nice formula. So, what's going on here with this somewhat intimidating looking formula? We have this symbol here, which is a Greek letter sigma, and we have a big radical, big square root here, and it looks like we're doing something similar to mean because we're adding a bunch of things up and then dividing by the number of things that there are. And we actually see the x bar, which is the mean itself. And so let's take a look at what's happening here. The first thing that we would need to do is we need to calculate the mean. After we've calculated the mean, we're going to subtract the mean from each and every data point that we have. We're going to end up with some positive numbers, some negative numbers, just to figure out how far away from the mean each value is. And what that's called is the deviation. After we do this, we're now going to take each of those deviations, which are all of these subtractions, and square them, raise each one to the second power. This will eliminate any negatives. We'll only be dealing with positive or zero values. After we square each deviation, we're now going to add them all up and divide by the number of deviations. What that is that's actually finding the mean of the squared deviations, and we call that variance. And then finally, once we've done all of that, we're going to take the square root of our result. Now, the good news is we're not going to be relying on simplest radical form here. For anything like this, it's calculator work, so we're going to be able to just use a calculator, find an approximate answer, or maybe an exact answer if we're really lucky, but we don't need to work through simplest radical form here. And there you have your 5 steps to determining the standard deviation. And we're going to see if we can apply these steps now and then see what the point of them is based on the data that we have. So let's give it a shot. All right, so let's take a look at Steph Curry's shooting or scoring data once again and see if we can figure out the range and standard deviation. The range is what we'll start with because that's pretty quick. The range of Steph Curry's scoring is just the highest value minus the lowest value. So I've just taken the data that we had organized in order to determine the median. And to figure out the range, we just do 40 minus 18, which gives us a range of 22 points. So the difference between his highest scoring game and his lowest scoring game is 22 points, which is a pretty decent spread. I mean, 40 points is pretty high and 18 points is low compared to what he does on a typical game, but that's about what it is. Now the 22 there is not really connected to the measures of center. It just tells us how big of a spread that is. Standard deviation, a little bit more involved. So let's revisit those 5 steps and see what we can do. The use of a table might make this a lot easier to understand. What I'm going to start with is I'm going to put all of my data values in for my list from 18 up through 40. If I have repetitions, I include them. You see I've got 222s, 223s, etc. In the second column, I list my mean, which I already calculated to be 29.2. We found that previously. Then I'm going to subtract the mean from each data value. Now this is something you can use a calculator or a spreadsheet for, and you'll notice that I start with large negative deviations. They become smaller and eventually become positive deviations, getting larger. That's because the 18 is 11.2 points below the mean, and 26 is only 3.2 points below the mean. Once we get to the 32-point game, everything else ends up becoming above the mean, culminating in 40-point games that are 10.8 points above the mean. So I take each of my deviations and then square it using a calculator. Negative 11.2 squared goes up to 125.44. And you'll notice here what's happening is I get to be a smaller deviation, positive or negative. My squared deviation is going to be a lot smaller before it grows up, getting over 116 for the 40-point games. So those are the first couple of steps to find the standard deviation. Now I need to average all of these squared deviations in order to find what we call the variance. To find that average, or the mean, I add up all of the squared deviations and then divide by 15. So using a calculator, we are able to determine that the sum of the squared deviations is 832.4. Divided by the 15 values there, we get about 55.49, or approximately 55 1/2. So that's the variance. And now to find the standard deviation, my final step just involves finding the square root of that number, which is going to give us about 7.45. This would mean that we'd expect in a typical game for Steph Curry to score within 7.45 points of his mean of 29.4. So if we rounded to say 7.4, we'd expect most games the maximum he would score would be around 36, and the minimum he scored would be around 22. And you can see that almost all of the games have a minimum of 22 and maximum 26. It only would leave out 5 of those games. So 2/3 of the data would actually fall into that range, which is pretty substantial. So that's standard deviation. It's lengthy and it's complicated, but it's not particularly hard if you just use a calculator and take your time. There you go. Let's talk about the same outlier we mentioned before now. Alright, so let's take a look at the same outlier that we considered in the other video. If in Game 1 of the NBA Finals, Steph matched Wilt's feat of 100 points, we discussed already the effect that would have on the mean, the median, and the mode, the measures of center. And I just want to talk about the effect it would have on the measures of variance. An outlier typically has a very large impact on the measures of variance because it is talking about the spread. And so it affects the range huge. It would affect his range from 22 to 82. This would mean that his best game was 82 points more productive than his least productive game. Certainly a much bigger spread than the 22 that we had previously calculated. And standard deviation, if we went through that whole process, again, standard deviation would more than double 7.45 going all the way up to 18.59. This would mean that we'd be expecting in a typical game for Steph Curry's point total to differ from the mean by around 18.5 points. Well, that's probably true that most of his games were 18.5 points above or below the 33.6 of the new mean. That's as high as 52 and as low as 15. As we saw, most of the games are in a much tighter neighborhood than that, and so that's why their old standard deviation would be a lot more reasonable. So that's if you're looking for good practice, what I'd recommend is use that 100 and go back and find the standard deviation. Make sure you get to 18.59. Follow the process that we did on the other page, and that's all you need. All right. Hope that this example makes sense and that now you feel like a master of this data analysis.